Hello students, today we're going to look at similar figures. Now I know that we've talked about similar figures when we talked about dilations because dilations form similar figures. When I use the scale factor and go from one figure to the next, they are similar figures because they have exactly the same shape but they're different sizes. So in order for similar figures to be similar, they have to have the same shape but are different sizes. Okay, and we need to know about similar figures so that we can sometimes find the length of missing sides of similar figures. Okay, so it's important to know also that the corresponding angles of similar figures are congruent. That means they have exactly the same measurement. The corresponding angles, that's the angles that are in the same position in each of the figures. Now I have two trapezoids here. One is turned upside down, but each of the angles is marked with these little curves inside the angle to tell me which angles are actually corresponding. Okay, and so we're going to write some congruency statements here. This little symbol in the middle is the equal sign with the wave on top. That means congruent. That means it's exactly the same. Okay, so we're going to start with the angles with the one stripe. And so we have angle P is congruent to angle Z because Z on the other trapezoid has one stripe. So we can just look at the stripes to figure out which ones are corresponding. And then let's go to two stripes. Two stripes would be angle O and angle Y. Angle O and angle Y. Okay? Now another way that we can identify the word angle is we can just draw the symbol of an angle. Don't make it a capital L because it's not a capital L. It's bent enough that it looks like an angle. And so we're going to put those there. And so we want to go with the three stripes now. The three stripes is angle N and angle X. So we know that angle N is congruent to angle X because they're corresponding. And then the last one is the four stripes would be angle M and the angle W. So I'm going to put angle M and angle W, because they both have four stripes and they're in the same position. If we took this small trapezoid and rotated it, we would see that those would be the same position of each angle. Okay? Now, let's look at the corresponding sides. We know the corresponding sides are not congruent because they're not the same size. So, but they are proportional. Remember, in order to make similar figures, we have to use a scale factor, and so we use the same scale factor for both the x and the y, which makes it proportional. So we need to also know how to write the proportionality statements for each one. Okay? So again, we're looking at lengths of sides this time, not angle measures. Length of the sides. So let's start with the large trapezoid, because it's on the left, and we're going to go, the first side we're going to do is from the angle with one stripe to the angle with two stripes, and so that's 15. Now what's the side that corresponds to that on the other one? Well, we find angle 1 and angle 2 and see what's between them, and that's 5, so it goes in the bottom. Now if I wanted to, I could have put 5 on top and 15 on the bottom. That doesn't matter, as long as I'm consistent. Now, all of the sides of the large trapezoid have to go on top, and all of the sides of the small trapezoid have to go on the bottom. If I would have put the 5 on top, then all the small side would go on top. But we're going to stick with it the way it is here. So now let's go from the distance between angle 2 and angle 3 would be 22.8. So I write 22.8 on top. And between 2 and 3 on this trapezoid is 7.6. And then we're going to go from side between 3 and 4. That would be 45. And between the angle 3 and angle 4 on this side, the corresponding side is 15. Remember, these are called corresponding sides because they are in the same position on both shapes. And then the last one would be the one between 4 and 1, which is 24. And between angle 4 and angle 1 would be 8. And so these are all the proportions that I could set up. Now I'm not going to ever have to do all four proportions at the same time. I just want to make sure that you understood how I could write the proportions with the corresponding sides. Because the next part of this, I'm going to fold my paper, is using similar figures to find the lengths of missing sides. Okay? We know that similar figures have sides that are proportional. So if we're finding a missing side, we want to set up a proportion. So I'm going to go ahead and set up my proportion. I always like to start with what's missing. So I'm going to put x right here because it's missing. Now, the first way I could set up a proportion is to find the side on the other triangle that is corresponding to x. And if we look here, it's 7. So now the x is on top, so the 5 has to go on top. And then the 5 corresponds to 10, which goes on the bottom. Now, you might be thinking to yourself, Mr. Cohens, that's not the only way you can set up that proportion. And you're exactly right. There's another way I could set up a proportion. And we're going to do that over here. I'm going to do it in a different color. I could take the same x, let me go ahead and set up my proportion, but I could put the 5 under the x, and I could put the sides of the same triangle in one of the ratios. And then the other ratio would be the sides from the larger triangle that correspond. So x still corresponds with 7, so it's going to go on top. And the 10 still corresponds with 5, so it's going to go on the bottom. So just to recap, if I want to use the corresponding sides from the different triangles, I could set them up in one ratio, or I could do the sides of the same triangle as another ratio. Your choice, just be consistent. Okay? So now let's solve these. You remember how to solve a proportion? Yep, cross multiply. So I'm going to do x times 10 is 10x equals 5 times 7, which is 35. Divide both sides by 10. So x equals 3.5. Now, did that work for the other one? Let's try it. X times 10 is 10x equals 5 times 7, which is 35. Oh, they're exactly the same. Divide by 10, divide by 10, so x equals 3.5. Fantastic. So now we use the properties of similar figures to find the missing side. Well, let's do the same thing for this number 2. How tall is the man? Do I have enough information to solve this? Actually, you do. Because now we have 2 triangles. I'm just going to draw a line straight down that man. And I'm going to create 2 triangles. I'll trace the first one in red. The second one is the one that includes the tree. That is the entire large triangle. So I've got 2 triangles. And what we know about triangles is a triangle inside another triangle is similar to it. Okay? So I've got a small triangle and a large triangle, and I need to see how tall is the man. So let's use h because it says h feet. And I'm going to start with the corresponding side of the larger triangle, which would be 25. Now the other side of the man's triangle is 5. And the other side of the large triangle is 20. So I have my proportion set up. And I bet you're saying, Mr. Cohens, that's not the only way you can set up that proportion. Well, you're exactly right. I could also do h, because I like to start with h, over 5, because they're parts of the same triangle. And then h corresponds with 25, so 5 corresponds with 20. And now we can solve it. Cross multiply. 20 times h is 20h equals 25 times 5, which is 125. And if you need to use your calculator for this, you can. Divide both sides by 20. So that means h equals 6.25. And again, if you need to use your calculator, you can. And let's try this one. H times 20 is 20h equals 5 times 25, which is 125. Cross multiplying. Dividing by 20 on both sides. So h equals 6.25. It doesn't matter which way you set up your proportion as long as you stay consistent. And I bet you thought that was all. But it's not. Because there's a back. You have 2 problems that I want you to find the missing side of. Do it right now. As soon as this video is over, I want you to solve these 2 problems. Find the length of x, the missing side, by setting up proportions for both of them. And then we will talk about those in Math Workshop.